All right. Hello, everybody. This is Miss Piekarski. As you can see here, I've got a little treasure map, and we have this pirate right here, and he needs to get to the treasure. Well, on his map, the map tells him that he needs to go up, or he needs to go north for 4 miles, and then east for 3 miles. And he can go that way, but everybody knows that the closest distance between any 2 points is a straight line. So another method he could do, or another way he could go, is he could go this path here. And if you recall right triangles, you can do the Pythagorean theorem to figure out the distance from here to here. Hopefully this is all a review. And so if he goes on the hypotenuse, or the straight line, then he only has to travel 5 miles instead of 7 miles. Okay? So this basic concept, I know it's really boring, you've seen it and done it before, but we're going to apply that Pythagorean theorem, the hypotenuse, to lots of different scenarios in this unit. And what we're going to be looking at or focusing on is called vectors. And let's say you need to know how to get somewhere. So how do you get to the bus stop? And with vectors, you have a direction and a distance. Okay, so we're combining those two things. So when this guy replies, go north for 2 blocks, well, the north is the direction, and then the 2 blocks is how far to go, or the distance. All right, so a couple things you need to know. These are in your notes, so make sure you fill out all the underlined parts. There's 3 different things you need to know about vectors. You need to know about the components. So you're going to count the number of spaces from the dot, or the starting point, to the arrow like coordinates. So if you're going left, then it's a negative. If you're going right, it's a positive. If you're going up, it's positive. If you're going down, it's negative. So very similar to your coordinate, or your grid. If you have a y and an x axis, let's see, there's x, this is y. This is positive. If you're going up, it's positive. If you're going to the right, it's positive. If you're going down, it's negative. If you're going to the left, it's negative. Okay, very similar to our xy coordinate grid. Okay, so those are called components. We'll get more into that in a little bit. Now your magnitude is the same thing as distance. The reason why we say magnitude instead of distance is sometimes you could this could be a force too. And then later on, when we start applying vectors to real life situations, it could be force or speed or distance. There's a lot of different types of magnitude that you can have. But initially, when we first start out, it's mainly going to be distance. Okay, and that tells the magnitude, or the distance tells the distance or the length in coordinate units from the dot to the arrow. The distance may have to be determined using the Pythagorean theorem or the distance formula. Okay, so I know we're all very familiar with the Pythagorean formula. We'll do a refresher on the distance formula in just a minute. All right, so with vectors, you have distance and direction. The direction tells the rotation angle associated with the picture, where the dot is the center of rotation, 0 is the positive horizontal direction, and 180 is the negative horizontal direction. Okay, so I know we are used to having an x and y axis, and our origin would normally be the starting point with our rotation angle like this. Well, there's sometimes, if you have a grid, okay, like this, you have several different lines, right? Well, if you start here and you rotate this way, then this would be your rotation angle. Okay, if you start here and you're going this way, then your rotation angle would be from here to here. So it doesn't matter where your point starts, wherever that dot is, that's your starting point. Okay, and then the arrow, I know in previous units, when we worked with the XY axis, the arrow means that it keeps on going. With vectors, your arrow point just tells you what direction and when the end point is. Okay, so don't get those confused with thinking it's going to keep on going forever. Let me erase that. All right, so vectors are defined as directed distances. This means that as well as having a specific length, they are also described by their direction. So that's the key difference between normal lines and angles and vectors. Okay, we're kind of combining everything. Vectors can be represented on a coordinate plane as arrows drawn from a initial point called the tail to the terminal point called the head or the tip. Okay, guys, these are all very similar to things that we saw last year in the first unit. I know this is a lot of information I'm throwing at you right now, but it's really not that difficult. There's not very many formulas you need to recall and memorize. So just make sure you understand the concept that this arrow does not mean it's going to keep on going. Your vector stops here. This is the end or the terminal point, and this is the initial point here. All right, so symbolically, vectors can be represented as bold lowercase letters such as V, or much like a ray, for example, the ray RP. So from here to here, this is vector RP. However, the arrow as a vector does not mean it continues forever. It simply indicates the... Oh, well, it will not erase. Oh, my goodness. So let me tell you what this says. It indicates the direction of the vector, which terminates at the indicated path. So that's something we've already covered several times. So right here, you should write the word direction. All right, and then let's look at your table of formulas. I know this looks like a huge mess. Let's break it down step by step. You have 3 different terms you need to know: components, magnitude, and direction. For components, remember we're using these kind of open and closed arrows for our in place of our parentheses to indicate it's a vector, not a coordinate point. This would be your x value and your y value. So your horizontal direction and your vertical direction here. The ordered pair used to represent a vector. If vector v has initial point x1 and y1 and terminal point of x2 and y2, then you can find the coordinates like this. So that's the components for your vector. That tells you from your starting point how far you're going to go left or right and how far you're going to go up or down. Okay, now the magnitude, you symbolize it with the absolute value signs with the V or for a vector in between. That's just how the length of your vector, so the length of the line. A lot of times you're going to use the Pythagorean theorem. All right, so now the direction is the symbol we just used, theta. This is just our direction or our angle in either radians or degrees. Most of the time I think we're going to be in degrees. Every once in a while we'll get radians. Just keep your trig table out and don't forget how to change the between radians, degrees in your calculator, okay? So now the definition is the direction a vector is pointing measured as a rotation angle from the positive horizontal axis, okay? Now, our components, before we get into this part here, we need to look at our components. We're using our A and our B, so our X and our Y, and if we have our components and we want to know the direction, then we are going to use the inverse tangent formula. Remember, the ratio for tangent is y over x. Okay, y is going to be our b value, x is our a value. And if I know my ratio, then I can find my angle by doing the inverse of that, tangent. Okay, but sometimes we will have if they're both positive, if we're here, then we can just do inverse y over a and we'll get the right information. But what if we have a negative x value? If it's over here, then a or our x is a negative, then we need to add once we do the calculation inverse tangent of y over a, we're going to add 180 degrees. But if our x or if our a is 0, let's say we're going straight down, okay, or straight up, then our direction, in this case, it would be 90 degrees. In this case, it would either be negative 90 degrees or 270 degrees. Okay? If we're on the positive x-axis, if I'm trying to draw a straight line. If we're going straight to the left, it's 0 degrees. If we're going straight to the right, it's 180 degrees, okay? So there's sometimes that we are not going to have to use this inverse tangent, and there's sometimes we will, okay? The biggest thing is to look at your x and y values, or your a and your b value, and see on what quadrant you're in. That will help you figure out when you have to add 180, or if you're just adding or subtracting 90 degrees to it. A vector is said to be in standard position if the initial point is at the origin. When located in standard position, the components of the vector match up with the coordinates of the vector's terminal point. Define each of the following in terms of x and y and magnitude. So let's think back to our unit circle. If this was my unit circle, this would be my x and my y, and my cosine ratio would be x over my radius, or my, in this case I'm using the vector component or magnitude. So for cosine theta, it would be x over the vector magnitude, and for sine it would be y over vector magnitude. Okay, but what if I wanted to get x and y by itself? So in this case, I want to solve for x. Well, all I have to do is multiply both sides by the magnitude. And so if I wanted to solve for x, it would be my magnitude times cosine of my angle. If I wanted to solve for y, or get y by itself, I would multiply both sides by the magnitude, and I'd have magnitude times sine theta.